With this lesson, we're going to take a look at just an additional trigonometric function. We're looking at the sine and cosine sum formulas. Notice that the sine formula and the cosine formula are looking at the sum of two angles, U and V. Or we could also look at the difference, and I'll talk about that in a moment. So you can just read the sine formula yourself, and then consider that if this were a minus, so if I just take and say I'm going to have a minus here instead of a plus, then I would have a minus here instead of a plus. And for cosine, the cosine formula, it's the opposite. If I had a minus, the difference between u and v, then I would have the sum of these two expressions, this cosine u, cosine v, and sine v, sine u. So let's just look at a few applications of this formula. For one, let's go ahead and start off with what we're really familiar with, which is we probably have been, if you're watching this video, you've probably been doing some verification of trigonometric identities and some simplifying trigonometric expressions. So if we take this expression here and say that we want to simplify it, then using the sum formula, I can do sine x cosine 3 pi plus sine 3 pi cosine x. And then, of course, this cosine 3 pi and this sine 3 pi, I'm going to be able to evaluate. So cosine of 3 pi it's going to be the same as the cosine of pi, right? If I think about a unit circle, I'm going to go around once, that's 2 pi, and then another pi. And at that point, I would have -1, 0. Of course, you could just find this on your unit circle, and we're going to take the x-coordinate for cosine. So the cosine of 3 pi is -1. You should be able to follow that discussion. And then the sine of 3 pi is going to be the y-coordinate at that point, which is 0. And simplifying this, I've got -1 times sine x is negative sine x. And here we have 0 times cosine x, which is 0. So we have simplified this. And then if you just consider if this were given originally, if we were just given sine x plus 3 pi is equal to negative sine x, then it would be an identity which we could prove by using the sum formula for sine. So in this respect, this is just another trigonometric identity that we can use to make substitutions when we're simplifying or when we are verifying, proving identities. And it's as simple as that, just adding another identity to the list. But there is a numeric application that I would like to take a look at, which shows the utility of these functions. So here I've got sine of 15 degrees, which you should know is not on our unit circle. So what would we be left with? We would have to enter that into a calculator. But using the sum formula, I can notice 15 degrees is equivalent to, that 15 degrees is equivalent to 45 degrees minus 30 degrees. Now you might notice that I'm set up here in a position where I can use this formula, this sum formula. So let's go ahead and do that. And I'll say that I have sine 45 degrees cosine 30 degrees plus, no, it's a minus because I've got a minus here. So it'll be minus sine 30 degrees cosine 45 degrees. Now these I know. I know the sine of 45 degrees is rad 2 over 2. I know that the cosine of 30 degrees is rad 3 over 2. I know that the sine of 30 degrees is 1/2. And I know that the cosine of 45 degrees is rad 2 over 2. So what in the beginning it looked like I would have had to use a calculator to find a decimal approximation for this, turns out to be, with the sum formula, an expression that I can evaluate exactly, getting rad 6 minus rad 2 over 4. Okay? Now let's take a look at this. This is a little bit, I would actually, so here this is in radians. So can I think of a sum of radians that I know that comes out to 7 pi over 12? That's probably a little bit tricky, and we'll come back to that in a moment. But let's take the 7 pi over 12. I'm just going to take 7 pi over 12, and I'm going to convert it to degrees. So I'm going to go 180 over pi radians. And what will that be? 6 goes there twice, 6 into this 30, 2 into that 15. So I've got 7 times 15, which is 105 degrees. Okay, so that's what I want to use back here instead of using the radians. And I'll be very clear why in a moment. So we've got cosine of 105 degrees, which is cosine of 60 degrees plus 45 degrees. And then I can use the sum formula for cosine. And I'll go cosine 60 degrees, cosine 45 degrees, minus, using the formula, because when I've got a minus for the cosine formula, I'm going to have the plus for what it turns out to be. So sine 60 degrees, sine 45 degrees, and then we know all of these, right? Cosine, the cosine of 60 degrees is 1/2. Cosine of 45 degrees is rad 2 over 2. Sine of 60 degrees is rad 3 over 2. And the sine of 45 degrees is rad 2 over 2. And we get rad 2 minus rad 6 over 2. Simple enough. Now, if I had not converted this to the 105 degrees, then what would I have had to figure out? I would have had to know that 7 pi over 12 is pi over 3 plus what? Pi over 3 plus pi over 4. All right, and so I could have maybe worked my way to that by thinking about what angles. I mean, I know I'd have to be using some variation of pi over 3, pi over 4, pi over 2, pi over 6, and looking at some combination of those that was going to get me the 7 pi over 12. But I would just prefer to convert it to degrees. And that's about it as far as the direct applications and examination of the sum and difference formulas for sine and cosine.